Hello friends, this video on surface chemistry part 28 is brought to you by examfear.com. No more fear from exam. Now we'll talk about the protection of colloids. We have seen that colloids are unstable, right? But if you see, this is my hydrophilic, they are more stable. Why? Because the particles love solvent and this is less stable. This is lyophobic, right? This is lyophobic. The particles hate solvent, and this is lyophilic. The particles love solvent, correct? So lyophilic is more stable than lyophobic. Why? The only difference in these two are is solvation, right? Solvation is nothing but the affinity, right? Affinity for these particles to get mixed in this solvent, right? The only difference, because both has charged colloidal particles, but the only extra thing this has is solvation. Solvation is nothing but desire of these particles to mix in this solvent, correct? Now, if there is a unique property of these people, that is the lyophilic sol or lyophilic colloids, they have a unique property of protecting these. Anyway, see, these are also particles, these are also particles, right? So they'll have some connection, correct? Some connection is there between these particles. So these lyophilic salts will have tendency or unique property to safeguard lyophobic. Let me write here. Lyophilic salts have tendency to protect my lyophobic salts. See, in the normal scenario, I have a sol, you keep it for some time, they coagulate. We don't want this to happen. We are protecting this now, right? It is a protection to this, and this will not happen. So typically it has been seen that these lyophobic salts, they have tendency to protect this lyophobic salt. How do they do? They do this by forming a layer around lyophobic particles, and thus they protect the latter from the electrolytes. And see, for example, I have, let's suppose, solution. Now in this I have some particles. So these particles are my lyophobic. They hate the solvent. Now if these people hate the solvent, but I somehow surround them with lyophilic salts. So let's assume that the black was the one which hate the solvent. I covered this black with the red ones, and these red ones are the one which love the solvent, right? So typically if you see, the black ones are all gone, they are embedded inside this red ones, correct? These all particles are covering this black ones. So with this, what is happening is the black ones are not in direct touch with the solvent. See, earlier the black ones hate the solvent, right? So they are unstable. Now these black ones are covered with these red ones, and these red ones love solvent, right? Now those red ones love solvent. This system will be stable, because the one which is hating solvent is totally embedded now. It is not in interaction with the solvent, right? So these type of colloids which are used to increase the stability of lyophobic salts are called protective correct. See, as I told, lyophobic are more stable because of the solvation. Lyophilic is more stable because of the solvation. Lyophobic are not stable because the particles hate solvent. Now this has been observed that these lyophilic salt, the one which loves solvent, they try to help lyophobic salts also, and they do it by forming a protective layer, because this lyophilic salts, the one which loves solvent, they'll get stick to this particles, the black one that is lyophobic, and the black particles which hate the solvent is totally covered, right? This is totally covered with the particles which loves the solvent. So with this case, this particular sol is stable. Thank you. Visit examfear.com to watch more videos, attempt free online tests, get free study materials, find tutors and mentors, and much more. Thanks once again.